In the previous video, we looked at what happens when we multiply something by the number 2. So 2 is an integer. It's bigger than 1. It's also positive. So notice that we had the stretch. Here, we're going to see what happens when I have a number between 0 and 1. So 1/2 is between 0 and 1. So we're going to see how that affects our function. Again, I know this is an absolute value function because it has the absolute value bars. So the very basic absolute value of x gives me my parent. And again, when I look inside the absolute value, nothing's being added or subtracted to that x. So I can say nothing is happening, and 0 means I'm not changing the value. And there's no adding or subtracting of a number on the outside of the absolute value. So I can say 0. Nothing is happening. That's plus 0 on the outside. So the vertex comes from here. So my vertex is 0, 0. And my axis of symmetry comes from the value of x at the vertex, which is x equals 0. So now I have to see what transformation happened. When we looked at this particular function, we saw that when this number was bigger than 1, it gave us a stretch by whatever that number is. Here we have a fraction being multiplied. I have to say it's a fraction less than 1 and bigger than 0 that is being multiplied to the front. So instead of the 2, I'm going to put in 1/2. And for those of you who have this particular ability, if I do alpha F1, this allows me, the first one there allows me to put a fraction in. So I'm going to put in 1 over 2, and I'm going to get rid of that other 2. So now I was able to write it as 1/2 absolute value of x. Otherwise, you have to put it in parentheses. So let's go to the graph and let's see what happens. Oh, this looks at first blush like it's the same as the parent, but actually it's been squashed, widened, or compressed. Compression means pushed down. If I were to take this and push them down, I would be compressing the function so it goes out wider. And in fact, that's exactly what happened. So let's go to our table. So we can see here we have all these like fractions here. Because this is a straight line function, I'm only going to do my integers. So at -6 I have 3. At -6 I have 3. 1, 2, 3. I'm not going to bother with any of those fractions. At -2 I have 1. So you can see it's already kind of like coming down from the slope isn't as steep. And at 0 I have 0. Let's see what happens. I'm going to go up. At -8 I have 4. -8 I have 4. Okay. And then, did I do -4? I missed that one. At -4, I have 2. So you can see it's already not as steep, so it's being compressed. And then I can do the other side. So at 2, I have 1. And then at 4, I have 2. And then at 6, I have 3. And at 8, I'll have 4. Okay? So you can see here what has happened to the function. So I'm going to go ahead and I'm going to draw in using a ruler, because this is a straight line, for the absolute value. So you can see here that if I were to take the parent function and I were to push it down, push that down, okay? So it's as if the parent function arms are pushed down. And anytime you have a push down, another word for being pushed down or squashed is a compression. Okay? So that means our transformation is a compression. And what caused that? By multiplying it by 1/2. So this was a compression by 1/2. And again, let's just go over a few things here that I kind of glanced over. So right here, this is my vertex, and my vertex exists at 0, 0. And my axis of symmetry, if I was going to draw it in, it goes through the vertex, and we have balance on both sides. The function looks like a mirrored image on both sides, so it's symmetrical. So that's my axis of symmetry that goes through there. So I would say that my axis of symmetry is at x equals 0, which I neglected to draw on this one. But it's the same thing that's going on.